Okay.
All right, so first things first, we don't have our audio system up and running, so you're going to have to listen to me being loud, or when you are talking or whatever, please be loud, because there was a snafu with the audio gear and it didn't arrive with the owner. So it'll be fine. The irony is we were actually going to do an experiment with another microphone in the middle of the room so we can better pick up comments and stuff if you're not actually mic'd. So here we had this great experiment, and it did happen, but that's okay.
We'll do it next time.
We'll do it next time. Give y'all something to look forward to.
Experiments that don't go well.
That's right. You only need the one that does. All right, trivia. Who made the first television remote control? Zenith.
Space Command.
Space Command.
Flashlight.
Flashlight.
Flash Med.
You're half right.
Lazy Bones.
Nope. It was Philco.
Philco.
Lazy Bones was the first one. Correct. The flashlight one came later. So you are correct, but the actual first one was a wired remote. Can you hear me? Yeah. Wired remote control. I'm sorry. Because people got tired of tripping over the wire, they went wireless. And apparently, if the TV was in the way of the sun, it would change channels on it. That's when the 8-year-old kid became the new remote, right?
Yeah.
All righty. We don't have any minutes for last month to review. Didn't get them compiled together. My fault. Shoot me. But there, you all were here. There was nothing business related. It was pretty self-explanatory. We'll go through old business, new business stuff. A couple of important topics on there. Then we have two, not one, but two great presentations. Randy's going to do the first one about what does it take to make a radio station? You know, besides an antenna and a microphone and a disc jockey, right? We'll take a break, and then Barry's member of the month. And we know the interesting stuff that he does with his hobbies and his radios and everything like that. So this will be very, very interesting. Then we'll do our club input section and show and tell, which is portable TVs. And we have nice portable TVs out there. All right, we're up to 121 members. I lied. It's actually now 122 as of this morning. I didn't get the slide update done. So that's great. That's great. Whole business is pretty straightforward. New business. I'm going to turn it over to Paul in a second, but I wanted to point out that we have our pavilion book. Thank you, Aries, for October 11th, right? Whatever it is in October. So we've got our fall swap meet locked and loaded as far as the building is concerned. So we'll start communicating, doing that stuff a little bit later. But again, thank you, Aries, for locking that in as early as we could. With that, I'm going to turn it over to Mr. Paul to update you on some of the changes that we're now involved with the club building facility and the status of our treasurer transaction. The floor is yours.
All right, I'm going to move in a little closer because I forgot the wires to hook up the amplifier to the speakers. They're in another box, and I didn't make it.
What, you're not wireless?
No, we are wireless, that's for sure. We're back down to pure analog now. I don't know how many, I know the officers of the club know this, basically, but the rec center, we have been operating under a very unusual set of conditions with them. And that is that normally when they have a bunch of people meeting in this place on a regular basis, you got to be members of the club of the rec center. And if you're a non-resident of Roswell, it's $42 a year. And it's funny because the sheet that tells you this says it's a lifetime membership, and then there's an expiration date on it, which is a year ahead. So. Anyway, Mary Rummel, who had previously been the director of this facility, retired about 3 months ago. We were told that everything's fine, we'll just keep doing everything the way we always have. We get a new set of people. Nikki Williams is the new director, and a lot of things have changed around here, and you because you're not involved in the whole process, you wouldn't see it because you just come in for the meetings. But the point is that even doing personal training like I do twice a week, the relationship between the trainer and the facility is different, and I won't go into any of that. But on the 16th of June, I got a communication from the rec center. I appreciate that you have been dropping off the attendance sheet after the meeting. I did notice that quite a few of the attendees do not have a current ARC Life membership. The annual cost for the membership is $28 for Roswell residents and $42 for non-residents. The membership will allow them to participate in the social activities, blah, 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 blah. Let me know if you have any questions. So what it amounts to is they're not going to let anybody in the building and participate without a full membership in the rec center. And Steve, I think you're the only one that's a member outside of the club that has anything to do with this. If everybody that's attending the meeting had to have a $42 membership, because I think hardly anybody is a resident of Roswell, we just weren't going to be able to have meetings here. And I let Lee know this, and I figured it was only a 20% chance that we were going to be able to continue to meet here. And so I went to the new director of the facility. She was very helpful. She listened to me telling her about what the arrangement was before. She did say right away that you can go ahead and have the July meeting. That's not going to be threatened by this. And so what we did was work out a deal that said if we get a number of the officers of the club we got to have some more chairs. If we could get the officers of the club some memberships, then we could continue to have the meetings. They do rent meeting space. You know, the hall, they'll have weddings, they'll have all kinds of events up there, over there, and that's a one-time thing. They'll let people come in the facility. Otherwise, we're here in an unusual way because it's monthly. It's a successive activity. So anyway, she was very sympathetic. She was willing to listen to what I said. She did not write that piece of that thing I sent you, that I read to you. And she went to the people in Roswell who run this whole park. This is part of the Parks and Recreation system that Roswell runs. And this facility is jointly owned by Fulton County and the city of Roswell. So they control who comes in here and what they can do. So she went on our behalf and got them to agree to continue this arrangement the way it had been set up before. So here we are, and the only thing they needed to add to this, you do need to sign in. You really do. And the point is that they need to know the name, the address, and contact information for everybody that's in this building. Now think about it. This is a facility owned by the city and the county of Fulton. And if anything were to happen to anybody that was here, they would not have any information to know how to contact anybody. They've got insurance. We have insurance as well, but it's liability. I don't know to the degree that it would cover an accident where somebody trips over a table and breaks a leg or something. I don't know how that would work. And the problem is when you start asking questions like that, you start getting answers you don't like. So what it amounts to is, as far as the people attending the meetings on a regular basis, you come in, you sign in. If you have signed in before and given your address and contact information, all you have to do is sign in, because when they get the sheet, they'll look it up, you're on the list, they've got the information. So anyway, we are still here, and we are going to be able to continue, as far as I know, for as long as the current management is in place. When and if that changes again, you got to face the fact that it is an unusual arrangement, and we've got to be conscious of the fact that it is, and satisfy their needs in order to have us on this facility. And it was, you know, I've negotiated a lot of stuff in my time, but in this case, it actually comes down to what amounts to begging, because, you know, I didn't have anything to offer them. It's all a gift to us. And Nikki Williams was our champion, and as a result of discussions with her, she got them to agree to let us continue this. Whenever the management changes again, probably have to go through something like this again. But we took out memberships for 3 of the officers, and that was a whopping total of $126. And I don't know if you've ever looked up meeting space, but a facility like this, to rent it, is like $150 an hour in this market. And so we are the subject of an incredible gift, and we stumbled into it in the beginning just because I was working out here, and just started to have a discussion with a woman who turned out to be the manager of the whole facility. I didn't even know it at the time. So all this has come down to the fact that we should be able to continue the meetings. Just make sure that for everybody that's here, they got your name, information, contact information available.
Do we need to put phone numbers?
Say what?
Do we need to put phone numbers on the list?
Yeah.
No, well, currently, we don't have that. That's a new form that was not part of, I can add it for next time.
Well, it says phone numbers, I thought it said on the show.
No.
It doesn't? We didn't get that on there, okay.
So we'll do it for next month.
We need phone numbers, okay.
Yeah.
So there was a period of time when we thought we weren't going to be able to continue to be able to use this facility. So and not only that, the restrooms, the coffee, the whole thing, that's still just the way it was. And we just need to be good stewards of their generosity. And I think we've been doing fine. We're a bunch of, usually most of us are a bunch of old guys, and we don't tear place up very often. You don't have any wild parties and carry on. So anyway, there was a period of time last month when I was really concerned, and it all worked out. And the message is that we're going to have to keep conscious of what this gift is to this club, and the fact that we have access to this facility with this, the setup that we have is just incredibly valuable to us in keeping this going. So anyway, I just wanted you to know that, and they have the right to demand that they know who's on the facility and how to contact them. And so we must comply with that, or we can't be here. Thank you.
Wait, you're not done.
Transition. Oh, treasurer transition, and the new treasurer has joined us. And we've already had one meeting. Now, I guess the only signature we're missing is Mark's. I think we can go to the bank with this and be happy. I've already changed the record with the Department of State of the state of Georgia. It cost us $30 to change the thing, but Eric is now, by their standard, the treasurer. We will now get together with the bank, and once the transition has occurred to the bank, he's going to get a whole tub full of stuff. And he's going to be the treasurer. And we have a number of issues to work out as far as wrinkles are concerned. It's like do I get to keep the card, the Visa card? Because I have to get the donuts. And if I don't have the card, I can't get the donuts. I have to. So, and not only that, you don't need a receipt because it comes up in detail, Krispy Kreme, every month. It shows on the bill.
Well, that's part of your job as treasurer of America.
You're going to have to pay a bunch of bills using the credit card information, and we can photocopy the card and you can use that. You have it. I think Aries has it.
I have what?
Don't you have a photocopy of the credit card so you can use it?
No.
If you have to renew some of your stuff, a lot of it I have done. But when you do it online, all you need is the information. You don't actually need the physical card.
But to date, you've always done that.
Okay, and we can keep. You can keep doing that.
I don't need a card.
No, I think I was racking my brain. The only thing I think we need the card for is the donuts. So anyway, we'll work all that out. So now what we got to do, once we have this signed document, Eric and I go to the bank, we work with them, we get their records changed, so now he is the treasurer, and when we walk out of there, he's the treasurer, and finally, in the end, I am not. Joy to the world. Thank you. Anyway.
I want to give Paul 2 shout outs. One, because of the change in process. Last month they walked in and they go, "Who are you?" And I said, "Well, are you a member?" "No." But well, you can't be here. "What do you mean I can't be here? I've been here for 2 years, 3 years." But that's when we found out that the rules had changed. And so right after the meeting, connected with Paul, I said, because he'd arranged all of this, like what's going on here? And so he bird dogged it. Meanwhile, Aries and he and I are kind of going, is there room at the inn? Is there room at the inn? And if you got a lot of money, sure. But it was not looking good. And but he had the right conversations with the right people, because we have a good relationship, a good stature with the organization. And obviously somebody in our field that supported us, in our backyard, he was able to do this. So I want to thank Paul for making this happen, because this could technically have been the last meeting of SARS, and which would have been the end of SARS, quite honestly, in my opinion. Because while people, I think, like going to the restaurant or whatever, it doesn't have the same appeal as this does. So thank you for that. And then I also want to thank you for all the time you've been treasurer, and that we had the delay before we actually got an elected treasurer. So he's been doing the job longer than he was supposed to. But I want to thank him for, again, making it work, and working with Eric to get it transitioned. So I want to give Paul a double Now, did I send you that message about the other problem we have?
You talking about the audio?
Get off the audio!
Yeah, well.
Trust me, they can hear me. We're going to take a 5-minute break, because right after we're going to set up for Randy's presentation, make sure it's all looking pretty. So it is, I'll say it's 9:20, 9:25. There's a question in the back.
No, I was just going to ask at the break if we could move that side tables up one, we can get one more table in for the overflow.
Okay. Good answer. Let's give a round of applause to White. That's beautiful, beautiful. Come back at 9:25. So, I would like to present a man of many talents. This man can climb 4,000-foot towers and change light bulbs at the same time. Nope.
I doubt that.
Not quite. Randy's going to do a presentation on what makes it a radio station. As I said, beyond beyond a tower and a disc jockey.
Yeah, this is really the story of a radio station, okay? In South Florida, I've been associated with for about 25 years, on and off. And, you know, how it came about and how it's very different from today. I mean, in the 1920s, the advertising was a little bit different. Most of you have seen movies and stuff. Oh, we're advertising Ovaltine and, you know, Kellogg cereals and whatever on the radio. Well, that was national. But one of the major things that they did was they advertised real estate. And real estate played a big part, in particular the stations in Florida, because they were trying to attract tourists. But anyway, we'll talk a little bit about that. This is a new transmission facility as of 2023 that was built in South Florida. That doesn't happen a lot these days. And it also is mostly, well, the first half of it's about the history of it. And this is And the Wonderful Isle of Dreams. Well, WIOD is the call sign of the station, which stood for the Wonderful Isle of Dreams. But anyway, a little bit of the same thing. The project was driven by real estate, and so we'll look at some of the history and how it originally came about, and including the founding of Miami Beach, where it was originally located. It's originally a narrow sandbar with swamps and mangroves, almost 3 miles out in the Atlantic. It's called Collins Island at one time because Mr. Collins populated it. This tells a little bit about it, where it's used for a coconut plantation. Owner sold 400 acres of the land to a planter named John Collins. In the early 1900s, he tried different crops, found success growing avocados of all things. But then some of his family came to visit, and they said, hey, you can bring tourists in. This is a great place. It's a wonderful place to visit. But he realized that wouldn't really work because he already had a lot of problem getting his products to market and a lot of cost involved. So he decided he needed to build a bridge. And he did obtain financing from some bankers, the wooden bridge, and upon completion, it would be the longest wooden bridge in the United States at that time. However, due to the high cost of the underwater concrete foundations, he ran out of money with over half a mile still to be completed. And I don't know if this guy has any relation to Reed, but anyway. Enter a man by the name of Carl G. Fisher. And Mr. Fisher was an entrepreneur from Indianapolis who made his fortune in the automobile industry. Not the Body by Fisher people, but he owned an early automobile dealership. It was involved in the Indianapolis Motor Speedway construction, the Lincoln Highway. Most importantly, he and a co-founder ran Prestolite. They owned Prestolite. And Prestolite made the headlights for almost all of the automobiles built back in that time. They were actually gas headlights. And he later sold it to Union Carbide, moved to Miami in search of new challenges and opportunities. And he met with Collins and agreed to fund the completion of the bridge in return for 200 acres of his property. The bridge was completed in 1913. The island was incorporated as a town in 1915 and officially became named Miami Beach in 1917. So Mr. Collins, of course, was an entrepreneur, and he was very involved in real estate. He envisioned Miami Beach as a standalone development, not a part of Miami. And he was a master of promotion. And by the mid-1920s, he had 4 luxury motels on the island, but he needed a better way to advertise his winter playground for the American wealthy. So he built a radio station. And the FCC history cards, we'll talk about that a little bit more in a minute. It shows that WIOD first went on the air in 1926. Little's known about the first year or so of the operation. We do know it was located on Collins Island, which is a part of Miami Beach. And it was originally on 1210 kilohertz, and it was originally owned by the Carl G. Fisher Company. This is just a little blurb about the history cards. This is the way the FCC used to keep up with applications. And these cards that began in the early 1920s. And they were just a card file. What's left today is, basically these reprints of microfiche records. It was all transformed onto microfiche. I don't remember the exact date. I think it's up here. But anyway, the cards, went through, started out with the Department of Commerce. And then, of course, the Federal Radio Commission in 1927. 1934, that became the Federal Communications Commission. These things kept being used up until they computerized all of the database for all the radio stations and television stations and all the rest of it in the 1980s. There was a project put together to preserve these because they were seldom used. Getting information off of them was almost impossible. Now they're available for probably, I don't know, maybe 75% of the radio stations in operation today. Some of them are forever gone. There was a hurricane, almost certainly the station was destroyed, if not badly damaged or whatever, by the Great Miami Hurricane in 1926. It shut down the whole area, real estate boom, and obviously impacted the tourist industry. We know, however, that by early 1927, WIOD was back on the air. They helped restore the tourist trade, its former glory. Now, it was originally located on Collins Island. I guess today this is South Beach down here in this general area, and Collins Island was right up there, about halfway up the island or whatever. This is a letter to a listener that talked about the facilities of the station, and it said that the antenna was hung between two 250-foot Whittlesey towers. Well, no idea what that means. I don't know if that was a manufacturer or the way to describe the four-sided towers. I've done a lot of Google searches and everything to see if we can figure out what that meant. And it seems to have nothing to do with communications towers, so maybe it's just a name a guy came up with. But they also talked about the ground system with 70,000 feet of wire buried in the ground in a what they call a herringbone fashion, submerged in the salt water that surrounds the island, and such as that. The photograph, which we'll see again here in a moment, is very hard to see, but you kind of see something going up here in the center. This just looks like two discrete towers, but there was an antenna hung between the two because that's the way they did it in the 1920s. Almost all of them were flat tops or T antennas. They were mounted on the building, of course. The building steel was often used as counterpoise, but when the supporting towers were ground mounted, a buried ground system was typically used. So, and I'll talk about the Minnesota, right here. But this is just kind of a graphical rendition of what the T-type tower, of course, these would be insulated on the ends. Very interesting to note that during the late 1920s, they operated primarily at night, when they could reach listeners in the northern states. And of course, the bands were quite different then, with a few hundred watts. You could pretty well cover half the country. So a guy named Jesse J was the director and announcer as of 1927. He's believed to have been associated with the station from its inception. Carl Fisher sold the station to him and his family in 1928. He was doing business as the Isle of Dreams Broadcasting Company. The Jays sold WIOD to the Metropolis Publishing Company, is that the way it says, in 1934. And they continued to operate as the Isle of Dreams Broadcasting Company, at least up until they transferred ownership to the Miami Daily News in 1940. Now, interference from new stations coming online may have been why Carl Fisher sold that station. As of by late 1928, they were sharing time with WQAM on 1240 and later on 560. They were issued some type of experimental authority on 560, possible to operate for extended nighttime hours. Most stations at that time signed off at midnight, but if a experimental operation may have been to operate well past midnight to see what happened. At one point, they were shown as sharing with WDBO. I think that was a mistake on 1120, but it could be. WDBO is in Orlando. In 1930, they were authorized for 1 kilowatt day, 500 watts a night on 1300, with 500 watts additional experimental, which again, seemed to be operating past midnight. They continued to operate from Collins Island on 1300 until the antenna system was destroyed by a storm, most likely the Labor Day hurricane of 1935. The station was operated from a temporary antenna for about a year and then moved to a new transmitter site located on the mainland, 18th Avenue and 32nd Street, is what the history cards say. Construction of the new site was completed in October of 36. The operating frequency remained at 1300 at that time. A year later, the license was given authority to operate on 610, where it operates today, between the hours of 1 and 6 a.m. local time to make measurements to determine if the antenna system would operate efficiently at that frequency. So in October of 1937, they were authorized to operate on 610 at 1,000 watts day and night, and they installed a modern RCA 1BD transmitter, similar to the one pictured here. Power amplifier consists of 4 UV 204A tubes. I don't happen to have any of those. This transmitter is probably larger than a 50 kilowatt transmitter today. They continue to operate from that site in the neighborhood of Alapatha. I've been unable to obtain any information about the antenna system at that location, but the coverage is almost certainly less, excuse me, due to a less conductive ground system. The next major change got underway 3 years later. Following the transfer of control to the Miami Daily News in 1940, an application was filed to relocate WIOD's transmitter site, install a 2-tower directional antenna system, and increase power to 5 kilowatts for both day and night operation. Well, that's a good bit of power in 1940. There was already 50 kilowatt stations at this time. So the new Isle of Dreams became what later was referred to as North Bay Village. But they purchased some bay bottom just off 79th Street Causeway and created a small island with a whole bunch of fill in Biscayne Bay for the new Art Deco transmitter building, which is shown right here. 2 320-foot Blau-Knox towers were built offshore on foundations resting on the bedrock of the bay, and construction of the site was completed. The station began operation for the new site in March of 1941, just in time. They were very fortunate that they were able to get it built before World War II, before America entered World War II. We'll get into that in a little bit. We're also very fortunate that that Western Electric featured the UWIOD installation in the May 1942 edition of their Pickups magazine. So lots of photos and details were presented there. The facility, as it says, was completed before America entered World War II. Otherwise, construction would very likely have been delayed due to the availability of copper and other materials. We know there's actually at least one station in Georgia that was under construction, and I think I have the in Savannah, and I have the diagram of the phaser design, which was the week of Pearl Harbor, and then it was several years before they could get enough copper to put in the ground system or to wire up the transmission line. That little island where WIOD was initially called Cameo Island, but the name would not last for very long. So the new ground system was plowed in. They have a few things here plowed with a boat. Consisted of 240 copper radials, 120 around each tower, each extending out to 350 feet. This is a fairly typical ground system for AM. We'll see another one of those later. The new A 5 kilowatt Western Electric 405B1 transmitter utilized a high efficiency Doherty final amplifier design with a pair of Western Electric Type 343 AA air-cooled tubes. Now, the 343A looks just like this, except there's just a cylindrical tube that was originally submerged in water because it was a water-cooled tube, and they added these heat fins to turn it into a air-cooled version. This is not a 343AA. This is an 892R, which was an RCA design, but it is very, very similar, same size. I've seen one of those, but I haven't been able to walk on it yet. But it looks pretty much identical to this, other than the heat fins are a little boxier, and that's about it. So, and it's very similar as far as the capabilities of the tube are concerned. That's a schematic diagram of their Doherty amplifier transmitter. It should be noted that the new directional antenna system had to be adjusted, followed by a proof of performance, which included many hundreds of field intensity measurements. We'll talk about that a little bit later. At some point, the north tower in the background of this photo, which was replaced, and some minor modifications, was placed on the same foundation as the original tower, but it was triangular. One source said it was replaced due to hurricane destruction. And, but anyway, the little island started to grow. They started filling more and more and more of it. Biscayne Bay was being dredged regularly, and new islands were being built from the dirt and rock from the dredging operations. In 1950, the South Tower was replaced with a guide structure that could support FM and TV antennas. And by 1956, the bases of both towers were on dry land as the area was filled to accommodate both a TV studio for Channel 7 and a combination studio transmitter building for WIOD. This is a picture from 1956, I think. I'm not sure about that. Maybe it's a little later than that. Yeah, a good bit later. Sometimes the 60s, I guess. But anyway, purchased by Biscayne Television Corporation, which also built WCKT-TV Channel 7. Biscayne was a joint venture between the Knight and the Cox newspaper families. Of course, those of us in that area are well acquainted with the Cox newspaper family. And they changed the call sign of the AM station from WIOD to CKR. The call sign was changed back to WIOD in 1963, and by 1964, it was owned by Cox Broadcasting Company, and therefore co-owned with WSB here in Atlanta. They retained ownership for many years, and they sold the station to a company called Paxson Communications. It was Florida-based in 1996. And WIOD became part of what is now Accurate Media, that I worked for, formerly Clear Channel Radio, in 1997. In this picture, the radio building is not shown. It's located to the right. It's the guide tower that you see right here. And here is the radio building at that time, and the self-supporting tower, North Tower, is shown behind. That looks like it was before it was replaced, though. That looks like a square tower to me. So, hard to say. This is what the island again looked like. This was in, I think these were from 2023, and this little area right here was blown up here. That's where the North Tower was. That's where the South Tower was. That's the radio building. TV building is here. The guide tower foundations are one of the guy wires was here, one was over here, and the other one was here. At this time of this photo, it had already been dismantled, but you'll notice that anchor is still out for that. This is a photograph of, we'll get into self-supporting towers later. Beginning in the 1960s, the Castro regime began to build radio facilities with express intent of interfering with U.S. stations that had potential coverage into Cuba. The FCC, in cooperation with the State Department, began allowing stations that were experiencing this interference to increase power, provided they did not interfere with other U.S. stations on the same or adjacent frequencies. And I think they also had to work some things out via NARMA for these power increases to occur and protect other stations in other countries that were nearby. WIOD was eventually allowed to increase power from 5,000 to 10,000 watts, both day and night, under special temporary authority. That SDA remained in force until we moved WIOD to the new site in 2023. So what is that, about 40 years, I guess, that they operated increased power. These were some of the sites of the 610 facilities, and then this one, it switched between 940 and 610. So they have these 4 different ones that were operating. We also have 620, 790, 710. These are some of the stations that had these Cuban SDAs, as they're called, were able to operate either day or night or both and increase power levels because of this interference. WIOD received authorization to increase power to 10 kilowatts in June of '81. And while the existing towers and ground system could remain, they'd have to purchase a new 10 kilowatt transmitter and phasing cabinet. There was barely enough room in the existing antenna tuning units for modifications to handle that increased power. And they were also required to complete a full antenna proof of performance. Patterns for day and night are shown here on either side.
So it went directional at night?
It was
More
directional day
directional.
and night. It actually had already been directional day and night. They just modified the patterns and changed them to protect terrestrial stations and other stations from the interference while increasing the power to cover the Miami area. The antenna array was first adjusted by making about, 5 to 8 field intensity measurements at the same locations on each of 12 radials. This is just a map showing the radials going out from the site. And then, they adjusted it to see if they could get it where it needed to be. Process that usually took, several weeks to get it just right. This is a guy that used to work for me that was making a field intensity measurement. And by the way, this is what the meter would look like in 1980s and 1990s, before they were all digitized.
So did they build houses upon the radials? Are these little
I'm sorry.
boxes?
These are measurement point
No,
locations.
but are these actual streets and blocks?
Oh yeah, those are streets.
And underneath this house is the radial?
No, the radial just means we drew a line on the map.
Oh,
And then we would go to various locations and
It's
make
not
measurements.
the actual draft, okay.
Yeah, so no actual construction of the radial or whatever.
So Randy, if you don't mind my asking, what exactly are they adjusting physically?
They would be adjusting, we're gonna get into that in a minute, but they
Oh.
would be adjusting the amplitude and phase into the 2 towers,
Okay,
the phase relationship between the 2,
right.
and the relative amplitudes between the 2. It's more complicated as you get into more towers.
Sure.
We'll see in a minute. That proof of performance consisted of approximately 1,100 field intensity measurements. That's just the report that was written up. So you can see it's got a lot of data in there, including maps and all kinds of stuff. About 50% of those were made on board a boat, and they were made with the station operating non-directionally using a single tower to determine ground conductivity. And that involved about 20 close-in measurements made over the first mile from the antenna, I think out to 2 miles actually. From 1 mile out to about 20 miles out. From 1 mile out to about 20 miles, measurements were made non-directionally in day pattern and night pattern both. And all about 100 measurements per radial were required, so that'd be 1,100, 1,200, somewhere in that neighborhood. One of the 12 analysis sheets where they graphically analyzed all this, you can see all these little circles up here were discrete measurements. This down here is the distance from the antenna system. And up here they actually have a curve that they fit to it to determine the conductivity of the ground. The entire process took a couple of months to complete. We cost in the neighborhood of $150,000 to $250,000 if undertaken today. So this type of field measurement analysis and adjustment is extremely extensive. By about the year 2000, the old guide tower was experiencing corrosion issues and needed to be addressed. And it was reported that a piece of steel from the tower fell and hit an automobile in the parking lot. There were no injuries reported. And a self-supporting tower was purchased to replace it. Only a partial proof was required to be completed. It's far less expensive once that tower was replaced. Generally speaking, when they were licensed by this method, there were always field intensity measurements involved. I was involved in the measurements from that facility was completed in early 2004. It's a whole lot less. Let's see. Yeah, it's only that thing. Only I don't know, probably 10 per radio, probably no more than 80 to 100 measurements in the partial proof at that point in time. Even the new tower and adjusted antenna system, the coverage from WIOD just was not what it had once been due to the construction of multiple high-rise buildings in the North Bay Village and surrounding areas. This map shows the predicted impact of the building on the WIOD night coverage. This outer one is what it was supposed to look like. This one shows what the buildings were doing to it. Of course, you'll see the very, very large gap out here. Well, some of that's not populated areas. I guess the areas that we're most interested in are these places.
You must have had to hire a bunch of Navy people to get some measurements out over.
Well, I think a lot of this was theoretical. I think the consultant, came up with this based on some spot measurements in various areas or whatever. But there was some dry land at this point in time for North Bay Village because you had, the islands to the east of it. I'm not sure what they did back in the old days when it was.
Hey, Randy, it seems like there's an awful lot of power going out into the water.
Yes,
It's for the fish.
Yeah.
Ships will start good.
that's right.
So maybe we can adjust those antennas.
Well, that's just it. They can't because they're limited. For instance, this null right in here, I think, maybe I'm not sure who it was protecting or whatever, but there were nulls in the pattern to protect other stations. So they were limited how much energy they could send in. But anyway, it was not real good. By early 2009, the rules were established to allow directional antenna stations to be licensed using computer modeling and sample system verification as opposed to field intensity measurements. This was a big change. It's referred to the method of moments, and the programs are based upon the numerical electromagnetic code, or NEC4. Most of you are hams, probably have at least heard of this, maybe even played with it. Due to dissatisfaction with coverage following the tower replacement, and we ended up relicensing WIOD using this methodology where the parameters were derived from the method of moments. Self-supporting towers are a little interesting to model because uniform cross-section towers, just straight, is really easy. You just, it has a diameter and it's broken up into segments, and wow, easy squeeze. But one that is self-supporting is a little more involved, so it ends up being a stack of cylinders. Each wire, of course, these wires, you think of a wire as being, this thin. Well, these wires were modeled out. They're like 24 feet in diameter. So it's really modeled as a group of cylinders when you get right down to it. That emulates the shape of the tower and allows it to be modeled. And let's see, I think that's, yeah. This looks a little thicker and everything, like it's a whole lot of stuff, but it's really a whole bunch of computer readouts. There's very little measurement data in here. There are a few field intensity measurements still required, but they're minimal. We'll get into that in a minute. The consulting firm of Nutrell, Lundin, and Rackley, located in Sarasota at that time, was retained to study possible areas in which to search for suitable property. But it took like over 15 years. Now, there were financial turndowns during that time and all kinds of things that happened that caused it to take that long. But it was no simple task to find a suitable location for the station. It was finally sited near Chrome Avenue and Taniani Trail. And that would be possible to build a 4-tower, 50 kilowatt facility for WIOD if we could locate to that location.
Wow, that's pretty far.
Oh, yeah. Oh, yeah, yeah, because this is, North Bay Village is what? I think right in here. I think that's the Kennedy Causeway. This is where the old wooden bridge was. I think the Kennedy Causeway is right there. And we're talking about all the way out, right in here, actually. No, there's Chrome. So, yeah, it's all the way out there. It does have that impact of the fact that it's further from the population, of course, but also further from tall buildings of worth of having. So the properties were found. They're located 69 plus acres. That was owned by the South Florida Water Management District. They're usually referred to by people as SWIFMUD. They don't like that acronym very much. But, everyone calls them SWIFMUD. And they're the guys that manage the Everglades, all the water resources in South Florida. And the developer who had purchased, I guess I got into somewhere, I don't know if I talked about the manager who sold off the site, but anyway, one of the managers wanted to move it so badly to improve the coverage, they sold the site to a developer. And the station was allowed to stay there. And I think they had like a 99-year lease, but there was a 5-story deed restriction on anything the developer could do to the building. Well, of course, they didn't like that. They had the right to find and pay for the station to move as a part of that deal. But again, it took like 15 years for that to happen. So that's the reason we began looking in this area. But that developer had some property that SWIFMUD needed, and for another project somewhere around Biscayne Bay, as a matter of fact. And so a deal was struck to provide us with a perpetual easement to install our towers in this area off Chrome Avenue in return for the property that they needed. And the site was infested with melaleuca, which is native to Australia. Now, I've heard that the U.S. government was somehow involved in planting melaleuca in Florida. It's kind of like kudzu, except it's trees, okay? Mitigation for our environmental impact for the installation of the new array, which is, as you can see here, it was designed for 4 towers, was to clear the entire 69-acre tract of all these trees and allow it to return to native grassland species, and to continue to treat the area so that the melaleuca did not come back. This over here is a plot of where the what the site would look like, the roads that go to the site. We'll get to that in a minute.
I have a question.
Yeah, go ahead.
Now, when you do 4 towers, you switch in between those towers and use those as reflectors, and also,
Give me a minute.
are they corduroys?
I'll answer both of those questions.
Settle down, boy.
Yeah. All good questions, but I'll answer both of them in a minute. So, access roads cover about 3.5 acres, and they're built up about 6 feet, so they're unlikely to flood. It does flood out there a lot. In fact, there's usually water standing all over the site most of the time. They got real fun building it there. The transmitter building and the what we call antenna tuning unit platforms, which we'll show in a minute as well, are 10 feet above grade, which is the estimated worst case storm surge for that area. If a 10-foot storm surge ever hits that area, there will be probably billions of people dead. I mean, it'll be really bad. It is highly unlikely. The SWIFMUD retains ownership of the site. The areas we occupy consist of the compound around the transmitter building, 4 tower bases, 12 guy anchors, access roads. The remainder of the site is a conservation easement. We did install a radial ground system we'll talk about in a minute. But those areas were allowed to return to nature as well. This is a picture, this is a Google Earth picture of what the site looked like in, what is that, 2022? This shows it in 2023. Looks like the building may already be there and the area where they had a bunch of stuff staged. And this just shows the roads and the area cleared. Here's a little better one. This is 2025 after the grasses are starting to grow back into the area. And it is now maintained in that way. Okay. Vertical radiators, as we talked about before, require a counterpoise. Most of your hams know about that. Vertical radiators for broadcast stations typically consist of 120 copper ground radials, a quarter of wavelength long. For WIOD, that consists of 840 radials, 480 radials, each 403 feet long. They are shortened and connected with a 4-inch copper strap where they would otherwise overlap. No reason to allow them to overlap. So there's about 25 miles of number 10 bare copper wire buried under the antenna array, along with almost a mile of 1/4 inch wide by 32 thousandths thick copper strap. Copper strap here, 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 and of course everything inside. Oh, here, here. These are the day and night directional antenna patterns. They're similar but not the same. Day power is 50,000 watts, night power is 20,000 watts. Okay. This talks a little bit about what makes up directional antenna system. This is not WIOD. This was a drawing I had from another station. I actually think this is a station in New Orleans. But, the transmitter feeds in out here. Okay. This is a matching network. Next is what we will call a power divider. This is a group of components that split the power, in this case, into 4 different parts, not necessarily and very seldom equal usually. There's various ratios here. After that is a way to adjust the relative phase of each one to one another. Now, you'll notice there's nothing there for this tower, which is tower 4. That's because this is what we call the reference tower, which means it will remain fixed in phase as the other 3 could be adjusted. Then we have transmission lines to each of the towers. And then there's a tuning unit here that matches the tower to whatever impedance the transmission line is, in this case 50 ohms. And each of these also has some form of phase shift. A lot of design involved. They must be designed to provide a specific portion of the energy to each tower with a specific phase relationship. With 2 antenna patterns, there's 2 of everything except for the towers themselves. And in our case, we use the same transmission line for each one, which, by the way, these are actual samples of the transmission lines that go to each of the 4 towers as it is installed. This is 2 1/4 inch coaxial line, 50 ohms, and this is 1 5/8. This one will handle about 35,000 watts, and this one will handle about 22,000, I think, at AM frequencies, much less.
I got a question for you.
You got a question?
Yes.
For your splitter, your power dividers there, what determines how much power or percentage?
That's part of the design of the array.
Correct. But
Okay.
so is the end amount being determined by how much the tower can handle itself, or?
No, it's okay. So let's see, back to, in order to create this pattern, and I think this side quit.
No, first button. First hat 20 has multiple features.
In order to create this pattern,
Yes.
it's almost impossible to see here, but you have a field ratio. So you want the field of tower 1 relative to the reference, in this case tower 4 is the reference,
Yes.
to be 83.5% what it
Okay.
is on tower 4.
Okay.
Yeah.
That's what's driving the amounts.
Yes. So there's a specified amount based on the pattern.
Gotcha.
And that's what gets into this design and makes it somewhat complex,
Absolutely.
is you have to come up with the right ratios, and then you also have to maintain the correct phase relationship between each of those, which is also specified in the pattern design. Okay, this is a schematic diagram of the actual WIOD unit, the phasing cabinet and the APUs. I messed it up again. There it goes. See, the transmission line, not showing much. I think I have it time. Transmission lines are shown in the middle here, here, and here. They range from 1,000 feet down to, 460 feet. To the right is what's in cabinets that are at the base of each tower. Antennas are shown here. And this is the actual power divider and phase adjustment. Sometimes the components are shared. We'll have a few pictures of those in a minute. The system used for the initial adjustment and monitoring consists of an RF current transformer. Like this. The copper feed going to the tower passes, passes through this current transformer and goes to the tower. And this is how the relative amplitudes and phase are monitored. These are connected back to the building with a piece of coax cable. We use half-inch cable, which is this LDF4. So this is an example of the cables that go back to this antenna monitor device on the right side. You can see in the rack here too. This one is in night mode, so it's showing power 1 with a ratio of 1 and a phase of 0. That's because 1 happens to be the reference tower for the night array. Oh, how does that work? Okay, that works. Okay. All right, so back to construction. This is the antenna tuning unit. Well, the towers, the tower base, the tower itself. Looking down, you can actually see part of the ground system. All of the foundations are board concrete caissons. There are 59 of them with depths of 6 feet to 15 feet below grade, depending on what they're used for. Tower bases, I think, only go down about 11 feet below grade. But the guy anchors go down, I think, about 15 feet below grade. This is one of the guy anchors.
Are these towers all in-fed?
They're all in base insulated.
Yeah.
They're base insulated,
Okay.
and then they're fed right at the bottom.
Right.
Yeah. And of course, the entire we'll get to how much of the steel is the radiator in a minute. It's called all of it, plus some of the guy wires. This is the transmitter building. This is like 25 by 36 feet. Emergency power generator, etc. But this picture is really here to show that there were just all these little foundations that had to be bored in everywhere in addition to the anchors. This is the building being constructed. These were supports that actually support the building and sit on the caissons. Little bitty crane there. Nick Blomstrand was involved in the project with me. Got a real kick out of this because he said, yeah, when they set up the 300-ton crane, they use a 100-ton crane to set up the 300-ton crane. He just found that really fascinating. But yes, it's pretty involved to set them up. This is sections of the building being hoisted that look like little toys, I guess, until you see people standing there. So. And there again, that's just the completed building. These are 4 500-gallon propane tanks. They're used for the generator. Diesel is not allowed in this area because it sits on top of what's known as the Miami West well field, which is to protect groundwater. They will not allow diesel in that area. These are just some pictures of the towers before they were erected. Of course, they were pre-painted, as you can see. And they're just laying out here with some of the insulators and all, ready to be erected. And they were actually put up with cranes. Now, that's not always the case for towers this small, but these days, I guess, for 4 of them and the cost of, labor and all that, they were able to erect 4 towers in just a couple, 3-4 days, maybe a day per tower.
If you didn't use a crane, how would you get it up there?
Well, you always use some type of boom truck or crane to set the bottom portion of the tower.
Right.
Then you put a gym pole on the side of the tower.
Oh, a gym pole,
And
really?
you do
Yeah,
that.
yeah,
So
yeah.
that's the way tall towers are. You
With a
can't
gym
use a
pole.
crane to erect a 1,500-foot tower.
And so you got guys up there wrenching on those things? If you use a gin pole,
Oh, yeah. Well, you have a crane, okay. Gin pole, you have a cable that comes out of the winch, goes up through it,
Right.
goes up top, comes back down.
Yep.
Connects to the gin pole, then the gin pole picks up.
Yep.
And then it's a two cable type of situation. So, but yeah, that's it going in. There are actually two guys, if you look very closely, right here, there are two men on the tower
hope they get paid well.
making a connection.
It's like for life insurance.
Yeah.
Said to be the most dangerous job in the world. I don't know. So,
That's not you up there, is it?
that's not me. No. I was young and stupid once, but I'm not anymore. This is some of the equipment coming in. This is, we had a porch, so to speak, that was, well, it wasn't really that, it's the pads we put in previously. The building sits on those pads. Let's see if I can see one. Yeah, here's one going up. So you had all these pads. Well, they stick out a little further to provide a porch area, which was very handy.
I noticed the propane tanks are a little lower than the generator.
Yeah, that was done on purpose because they didn't feel like they had to be a full 10 feet up.
And now we got the flow of the liquid or
Sorry?
the flow of the propane or just did it because.
I don't really know. I mean, that was,
What was the question?
the A&E firm kind of designed that aspect of it. One of the propane tanks are lower than the building, and the generator sits up here. And they're vapor, so there's no reason,
Well, it's not though. When it's under pressure and inside there, it's a liquid.
Yes, it's liquid
Propane
in
is a
here,
liquid.
but I'm saying
Yeah.
vapor is what the generator actually uses.
Yeah.
So, I don't really know. I think they just felt like, hey, if the water got up to here, it probably wouldn't matter.
If
You know,
if a tank
you know.
breaks and leaks, the liquid can't go into the transmitter building if it's lower like that.
Maybe that was part of it. Yeah, I don't know. I'll have to ask
Height of that
Keith
tower.
Mandusky one day why he designed it that way.
What was the height of that tower, by the way?
This tower is 300 feet of steel. Does not include the beacon or the base, or the base insulator. We're going to get into a little more of that in a minute. This is just a picture of a couple of the guys. This is Oscar. I don't know. I guess that's Nick setting the ATU cabinets. I don't know if I'm in any of these. Okay, ground system. That was real fun. In Florida, you have what is called muck. Normally, to plow on a ground system, you use this is a subsolar plow. You can't really see the whole thing. There's the rest of it sticking out. And you attach it to the back of a tractor. And right up here, you put your reel of cable, and you run it through the subsolar, and you anchor it some way, and you put the subsolar in the ground about 6 inches, and you drive the tractor.
Huh.
Okay, well, you try to do that in this muck, and the tractor, next thing you know, is about, 3 feet deep in muck and stuck, and requires another machine to draw it out. And they tried all kinds of things to figure out how they're going to put the ground system in here. The other problem is, and you wouldn't know this if you didn't do analysis and everything, but they did, is there are these limestone boulders that are buried underground. I mean, they're like, this big around, and they're just everywhere. And they don't show up above ground hardly at all. I mean, every once in a while you'll see one, but they're just everywhere, scattered out everywhere. So again, the tractor would hit one of the boulders, and then it would start sinking. So they came up with this, and he's sinking a little bit. They had a few little problems with that too. But they came up with this method of using this track backhoe and placing the plow right here on that, and then they take it into the ground, and they would just back the backhoe up. The guy had to drive backwards the whole way, but they had another guy on the outside out here directing him as far as where to go. This is just showing some of the copper strap around the base of this is the base pier of one of the towers, and I don't know if you can really see, but there's a gazillion ground wires here coming in this strap. It's located there. It interconnects the whole thing. I do have a picture somewhere, an aerial picture that gives a little more detail. This is cable installation. Now we had, again, towers 1 and 4, which are the ones further to the east, use this 2 1/4 inch coax 2 and 3 use this 1 5/8. That is a power level situation because the 2 outer towers have a higher power level than the 2 inside ones. And then we talked about the sample line. We have to way to control there are contactors out of the towers to switch between patterns. So you have to have control for that. So this is the type of control cable we used in that case. We send 24 volts out to pilot the relays to cause the contactors to move. The contactors actually operate from 230 volts, and then there's a 480 volt electrical circuit that goes to the base of each tower, where there's a step-down transformer to 230 because of the voltage drop, which is usually too great over that distance. So we send 480 volts out there and step it down to keep the current down.
Randy, what's at the base of the tower that needs that much power?
Well, we have tower lights. I'll show you here in a minute. We have tower lights and we have electrical contactors that switch.
Mm-hmm.
They're solenoid operated contactors that run 230 volts to switch between this pattern and that pattern. Towers 2 and 3 also have non-directional mode, so we can operate with just a single tower in case service is needed on the other 3. Then we have to go at very reduced power and operate non-directional. That capability as well.
Quick question.
These days we always design 2, so you always got somewhere to go.
Do you hot switch that, or do you?
No.
No.
We pause the transmitter switch and then bring it back up.
Okay.
Yeah. RFP from
I would say that would be.
This one's kind of interesting because these guys, the electricians, were a really good group, and these are all basically plastic conduits or whatever that they use. All the lines run through there, so they're trying to figure out how to get this, which is okay. This is supposed to be flexible. I'd like to see anybody in this room, really bend this. Yes, it'll bend if it's very long, but it doesn't bend a lot. So it's usually a challenge, and these were like, I think, 6-inch conduits, not like this. This guy came up with this thing. They would run their pulling rope through, and then they would push the backhoe up and wrap the rope around the trim right here, and then he would just put the thing in gear, and another guy would be out here pulling the rope in, and sit there. It was very neat to watch. So. All right, next. Okay, this is a little unusual. So this is a picture. It was actually everyone involved in the project at the time that we put the transmitters in. We decided we would do a time capsule. So everyone signed the forward. Now, anybody going into the site's not going to see this because this is underneath a 50,000 watt transmitter. But still, someday when they tear it down, they'll see Rudy's signature, Randy is right there. So yeah, this is the phasing cabinet, which showed a diagram of it. A little more into it, shows some interior pictures of that. It's 16 feet long and 4 feet deep, and I think a little over. Nick is 6 feet, so it must be about 7 feet tall. These are modern day 50 kilowatt solid state AM transmitters. They're a little deeper, but otherwise they're the size of a modern day refrigerator. Now, if we were 1937, our 50,000 watt transmitter wouldn't have fit in this building. So it's way different these days. This is an interior picture of the phasing cabinet. One of the doors open. We talked about those contactors. It's not a good picture. Maybe I have a better one somewhere else. That's what they look like. They do not stay energized. There's a solenoid here and a solenoid here, and they ratchet back and forth. So one position or the other. Nick working on the transmission lines now. I said this will hold this can handle about 35 kilowatts. So we have to have something a little bigger for 50,000 watts. So to hook up the transmitters to the phasing cabinet and such as that requires something a little larger. This is 3-inch air dielectric line, and it will handle 50,000 watts without a problem. The thing is, though, these have connectors on each end that are very difficult to install. It's hours long for each connector, And so you put a connector here and a connector here. By the time you buy the connectors, you've spent more money and spent the time to put them on. You spent way more money than you would have to have used what we call rigid coaxial transmission. Like this.
Connectors fill those and.
Not inside. If it's outside, yes, they have to be pressurized with nitrogen or dry. This is a 3 1/8 inch rigid piece of transmission line, which is what we actually use inside. It is flanged on, well, if you use it outside, it's flanged, it has O-rings, and it's pressurized. But for indoor use, the flange is just used in the connector connections. I think there's one of the flanges right there. But we have these sleeves that can be installed, so we can cut it to specific lengths and install it with the sleeves. It makes for a much simpler installation. There'll be several pictures of that. These are the transmission lines going to the towers that you'll see. This one was a mistake. There are actually 2 connectors there. We did have to put connectors on a piece of the 2 1/4 inch because it didn't reach. Oops. More pictures of the inside of the phasing cabinets. As I said, there are four cabinets, 4 feet wide. Of course, you can see pipes going through, pieces of copper going through the holes there on the top and interconnect them. This is some more pictures of the rigid 3 1/8 inch line that connects the transmitters into the phaser, and various other pieces. There's even some spare stuff up here. Okay. A picture of Oscar working on one of the, I don't know what he's working on, probably missing one of the breaker boxes or whatever, but this is one of the antenna tuning units, showing some of the components. Again, there are contactors inside of this, 1, 2, like 3 of them. The inductors are, at this big around. Depends on the current rating. We did have to do some night work because, of course, the IOD was on the air from the other site, and this was going through. So this is probably part of the adjustment process. I was inside the building where there are no bugs and there was air conditioning running with the test gear. Nice to have young guys working with me. So, some of the same things. So we get it all installed and we turn it on, and there's a spur. A little problem down at 510 kilohertz. It wasn't supposed to be there.
Oh, yeah.
And this is just one of those things that happens. So, this was a filter cabinet. This was placed on the end of the phaser. And like I said, this was after the fact. The whole thing was built. And so we got to figure out how to interconnect it and put it back in. It actually kind of looks like this on each end. There's one filter on this side of the cabinet, and one on the back with a partition in the middle to shield them from one another. And they ended up notching 710 kilohertz and 510 kilohertz in order to make this go away. 710 is right here. It turns out that 710, whose site was 35 kilometers away, had lost their main transmitter site and had been operating from an auxiliary site 3.5 kilometers from her site for like 15 years. But there was nothing in the FCC records that said it because they requested a special temporary authority, and the FCC said, okay, we got the request, and we'll let you operate under the emergency antenna rules. We're not going to grant the STA because then if we do, you'll have to renew it forever. So it just kind of sat out there in limbo. So that's the reason we didn't know about it. Consultants didn't know about it. Nobody seemed to. And there was nothing we could do about it. We did have to correct the problem because it was being radiated from our station. So that was fun.
Yeah.
Sorry?
I mean, where did the 510 come from?
710 coming in through the antenna system into our transmitter and intermodding with 610 produced a spur at 510. Yeah, I'm sorry, I should have explained that. So, yeah, so you take second harmonic of 610 minus the interfering signal on 710 produces the spur at 510 by
Okay, that makes.
But it wasn't coming from your transmitter, it was coming on from your antenna.
I'm sorry?
It wasn't coming from your transmitter, it was coming from your antenna.
Well, the 710 was coming in through our antenna,
Yes.
and then the 510 was being generated inside our transmitter. And then
So you've seen on the spectrum.
some small amount of energy was still going out, and there again, it was like 50 dB below the carrier, but it has to be 80. So, yeah, there we go. Okay. I think it was a little over 100 when we got done, so we did okay. This is that same cabinet showing on the end of the phaser. This is actually a 75,000 watt dummy load, a 50 ohm load resistor that we use for testing. We had to scoot over in order to make room. From the back, it actually looks like just part of the phaser. They matched it up pretty nice to that.
Neat installation.
These are the cables coming up from the from the various towers, control cables, sample lines, all that kind of stuff. So.
I mean, how often did you use the dummy load? Once or twice during the initial setup, and beyond that, not?
Well, I mean, the dummy load's there, and I mean, the two transmitters are switched back and forth, so they always load a transmitter into the dummy before they put it on. Make sure it's going to come up okay.
Mm-hmm.
So it gets used pretty often.
Okay.
If there's a problem with the transmitter, of course, you have to repair it. That's what it's really for.
Oh, yeah. Yeah.
So anyway,
Lubricated and radiated.
Nick always liked to have a good grin when he's getting his picture taken. He's working on the control wiring to the controller, which is up here. This is a picture again of the toroid transformer with the feed line. Oh, sorry, the feed to the antenna is actually up here. This is the copper coming in and going down. I think they had a static drain up here that they had to connect to, which is why it goes around like that. Okay, this is test gear. This is a vector network analyzer. Various pads, my PC. There's another one of current transformers. Set up to measure. This is a measurement being made at the common point, as it is called, which is where the transmitter feeds in. I guess we were doing some adjustments for common point or some other type of measurement. I guess not even connected at that time, really. There were some challenges. We actually lost, this is a vacuum capacitor. What is that? 15 kV. That's about this big around, about this high. It failed, lit up real nice. And as I said, that's me sitting in the air conditioning. Okay. All right. This answers Roger's question to some extent. All four of these towers, this is part of the method of moments model. It's just a graphical representation. And these are supposed to be each of the four radiators. And you'll see this little triangle on top, which is formed by the top guy wires and a halo that goes around. It's really, really difficult to see in this picture. But the guy wires are physically connected to the tower here. They're not insulated. And they're insulated down here. And this extends the height of the tower. They go down a distance. This is 73.5 feet down to the insulator. And the result is that this vertical radiator, which is actually 67 electrical degrees at 16 kilohertz, has the same radiation characteristics as a 90-degree radiator. So it's simply a top-loading technique. Rather unusual, but, well, not that unusual. Not at low frequencies. I guess I was getting tired that day, I don't know. This shows a test of these current transformers. We have 5 of them strung up with a cable going through. The network analyzer is feeding a signal through them. And then we set one as a reference, test each one, and make sure that they have the same amplitude and phase relationship. So they're not messing with us. Some field intensity measurements were necessary. As I said, this is a field intensity meter. There are later versions now. For about 25 years, they're very digital now, look a little bit different, but this is kind of the classic field intensity measurement. This is one of my PCs running this is a GPS receiver tied into it with a topographic map on it with the radials drawn out, and it tracks as we move around. We did have to use some specialized vehicles. This is one of the amphibious vehicles we use for some of the locations were easier to get to. And we have to do reference points, is what I guess they're called. I forgot how to use the word. There were maybe 30 of them in all. 3 on various radials that were specified in our construction permit. And after we've set everything up, these they don't do anything with these reference points. They're like for future reference. It's the reason I guess they call them reference points. But it's one of the least important parts of the whole process, but they still require it, particularly for a new construction. So this shows some reference points that are actually in the Everglades. I'll let the young guys have that fun. This is Oscar looking at the PC and trying to find the location. But yeah, they actually use airboats. There were 2 of them. This one I think was used on the northern radios, and this one on the southern. So that's just a screenshot of a few of the files and folders associated with this project off of my computer. So. And that's the end result. There's the AM station license, which was granted sometime in 2023. Filing date, grant date, October 23rd, 2023. So that's it.
So if you had a good receiver, would make it up here?
No. No, all the energy, because they have to protect the station on 610 to the west, okay, and some in the Caribbean and some in the Northeast, pretty much all the energy goes east.
East.
Yes. Well, Miami is east.
That's where you want
Okay.
it.
Okay. Yeah.
Yeah.
Go ahead.
Say something about
No, go ahead.
before the advent of computers,
Mm-hmm.
how do you design this thing to start with? How does that 4-tower array looks unique to me. And the question is, how the hell do you design something like that with the tools you had in 1990?
It was far more complex. There's
Yeah.
no doubt about it. I mean, there were people, but I mean, it's all a bunch of vector diagrams when you get right down to it.
Oh, yeah.
You know, plain and simple.
There was a station in Minneapolis on 1130 that had a 12-tower array.
There's one in Detroit. There's one in Minneapolis. We happen to own all 3 of them. There's one in Wisconsin, not Madison, but Milwaukee. There's one in Milwaukee. There's one in Detroit, and there's one in Minneapolis. And they're all 12-tower arrays on 1130. It look like cigars going up in the cab.
It's interesting because I've been interested in broadcast transmitter patterns for years and wrote a bunch of papers for them in the National Radio Club. And because most people that were interested in radios during that day were actually listening to the AM band, and nobody does anymore, I don't think. But the point is that this is the other side of that whole situation that people who collect radios don't usually think about very much. And a lot of the guys in the radio clubs just had no idea about why they couldn't get a 50,000 watt station 20,
3 blocks away.
30 miles away.
Yeah.
And when you see a pattern like that, that's close to Richmond, Virginia, 1140. That pattern is just like that.
WRVA.
WRVA. And if you're in one of the peaks, you get blown down, and if you drive 20 miles away to the west, it disappears completely. People don't understand why.
The TV station that I worked at, which was a UHF, had it was a 110,000 watt transmitter. But because the SWR the loss was so great on the coax, the stick was actually jacked up to 112. But the pattern was designed you had the major lobes north and south with minor lobes here, because well, you got the Bahamas over here, but other than that, who's ever gonna see it, right?
Right.
And the cows don't care.
Right.
So the whole antenna was designed to basically follow the coast.
Randy, are those towers run on DC ground?
No.
So they're up at,
Well, there is a static drain choke that takes it to DC ground, which is basically just RF choke.
okay, 'cause I was gonna ask you about that. What do they do for lightning mitigation?
Well, hopefully the static drain helps take care of it. There's always an output, a vacuum capacitor on the output.
Right.
To keep the pulse from hopefully propagating back in. And they do drain the static off of it, but that's about all you can do. So. But they are totally floating DC wise, except for that static.
Now, WLF in Chicago is a single tower. Tinley Park, Illinois, and WLF, you know, their transmitter tower is a single tower.
Right.
They have a small tower for standby in case the big tower comes down.
Is your question? Okay.
There's a,
Go ahead. I thought he did. Go ahead.
I don't know how many of you guys go to Charlotte, but in March for the radio club there, but WBT on 1110 has got 3 huge wall ox towers. Randy and I have talked about this. It's still on the air, but they've discontinued it. The transmitter site is off Nations Ford Road, and it's a 19.6 acre plot of land, and the land is more valuable than the station is. So the whole thing is up for sale, and they've got it running on a loop, and all they're doing is running a loop that says tune to our WBT FM on 107.9. And I can just barely hear that at night because of their nighttime pattern. But that whole thing is going to be torn down once that land is sold. And this kind of construction, I mean, building a tower like this, what was the price?
$8 million.
$8 million to put that transmitter together.
And nobody listens to AM anymore.
Well, WIOD has an audience, and they do make money. They make, you know, they gross $5 or $6 million a year.
Well,
Still,
there are stations that do make money.
yeah, WLW still makes money. I mean,
WBBM in Chicago makes money.
Yeah.
I mean, there's some of them that do. I guess WLW does as well. But anyway,
yeah, I've got KFAB in Sacramento is still #1 in that market, I think. And
When I was
WLW is #1 or #2. So yeah.
Okay, any other questions?
how many people have white radio like that?
Yeah, what?
White radio I used to be in the.
Oh, I don't know.
I used to worry about it all the time.
All right, well, thank you. That was very, very interesting. Brought back some horror stories from my TV days, so it's exciting. Let's take a 10-minute break. Let's do it. So next section is the club input. You have a question, you got to work on a project, you can pull on the wealth and the smarts of the room. Gary, you've got a question, and it's not up there. So I can do this. Anyway, so he's got a question about a device that he bought. I'm trying to get the picture up here. It's not cooperating. Well, while I get it up, why don't you go ahead and tell.
Yesterday I found a Silvertone phonograph, and it's a real simple one. It doesn't have a lid or anything. It's got a cord that apparently turns the turntable, but the needle is like a reproducer from an old Victrola that has a hand crank. And I can't imagine when they had the technology of electric, why they're still using a reproducer, with a steel needle, unless it's stuff left over and they decide to put the two together to get a product out. And you get the picture, there it is right there.
Yeah.
I figure it's 40s, it only plays 78s. Right. But why did they do that?
Save money on electronics. All you
Seriously,
needed to do was a motor. That's all you needed was a motor.
Right. But I mean, would that have been they had the reproducer just left over and just technology had caught up? I mean, that's kind of weird.
Do you know what it dates to here? Any idea what it dates
Can't
to?
find it online.
No?
I have the model and,
Yeah.
Google does not come up with anything.
Does anybody know when RCA started what they called the orthophonic Victrola?
Yeah, it was in the 20s. It was,
Yeah.
It was-
that's a big wide.
okay. Because that was the thing with Western Electric, that was involved with the design. Where's Jake?
That's gotta be over 20 years ago.
Yeah, I think it's 40s, but again, that's,
Like kids, yeah.
I mean, the whole reproducer business is exactly like you'd find on an old Victrola with
Sure.
the hand crank.
But it works and it's cheap.
It's supposed to work, yeah. I only got it like yesterday afternoon.
Because of the war?
Yeah. Well, didn't they see it?
For the war, for the troops, whatever.
There again, that could be a possibility.
It's a very
And
possible.
so that would have been the same type of thing, right, with the reproducer? Because
Yeah.
out in the field, you wouldn't have had electricity.
Exactly.
Right.
So they made, I think Sam Ashburn had one.
Yeah,
that
yeah.
was-
Sam has one from World War II that was a field phonograph.
Electrical motor.
Yeah, that motor, there's a motor that turns that plate, that platter,
That plugs in.
plugs in, and the plug is stiff, but the plug looks like it could be, late 40s or maybe changed.
But it very well could be that it was built during the war, because
Yeah.
I mean, the tubes and everything, you couldn't even buy them, could you?
The war always wanted metal, they even got rid of the copper penny and went to steel pennies to use the metal.
Yeah, but I mean, like RCA wasn't allowed to build radios; they were building stuff for the war.
They could build and sell limited numbers of tubes into the market
For
for
replacement.
MR, for
Okay.
maintenance and repair.
Okay. So that's probably it. They probably could not purchase. They could not build an amplifier because of the war.
Another way to date that would be, is that electric motor runs synchronous, in other words, it does display 78 RPM all by itself. Because in the 1927, when I did an Electrola and all that, which is the first one to have an electronic pickup on it, reproducer, it's electronic. And, restored it, but I didn't sell it, but anyway, that's another story. But they didn't have synchronous motor yet. So you still had the governor, where the synchronous motor didn't come out till later. Yeah, get us a picture of the motor.
Does it work?
Well, it doesn't have a regulator on it.
I'm sorry?
You haven't tried it.
No, I just got it
Because
yesterday.
it looks like it's got some water damage.
When I bought it, it says it works. It's in really good condition, I can't imagine it would.
And it's loud enough with that reproducer anyway.
You see the knob up there in the top left corner?
Yeah, that's a turn knob,
Oh, so that's the on-off switch. Then. Okay.
So it doesn't have the governor.
No.
Well, it may be the governor's
It'll be
adjusted on the
split
bottom
phase
of it.
motor.
It always brings
There's a
it.
lot of goofy things made around
With the solar
later in
companies?
the 40s.
Is that like the warrant switches? From
And then they were
under?
kitty phonographs
So,
for children.
I figured what the heck, I'll work out a picture today before I.
Interesting.
It's all their bills and then top.
What a wacky little thing.
Yeah, I mean, it's super cool.
Anyone have anything else they'd like to bring up?
Maybe you could answer a question.
Lee,
Yes,
show and sell? Did I announce that?
show and tell?
Sell.
Sells after
Show
show
and
and
sell.
tell.
Okay.
Show and sell.
Show and sell.
But you have to be careful of our time, because again, they're gonna be
Yeah.
a little
Yeah, we got
stricter.
another 13 minutes or so.
Picked out permanently.
Okay, so let's go to show and tell before show and sell. All right, who wants to play Vanna? Anyone? Anyone? I'm not sensing the love.
I'll do it.
What do you think?
So this is a 5-inch TV.
Tell us a little bit.
Well, I don't know a whole lot about it. I was cleaning out a relative's house. I found that. Never saw anything like it before.
It's on the Jetsons.
It's manufactured 2005, that's 21 years ago. It has batteries, well, there's no batteries in it now, but it takes 8 C cells to run it. It also has an adapter, which I don't have, but I've never turned it on. I looked it up on the web. Actually, Amazon is where I looked it up. And they were selling them, except they were out of stock. So this may be the only one in the world, I don't know.
That's a regular, it's a CRT.
CRT? Well, I like in the paper it says flat screen. Sort of flat.
Not quite.
Pretty light.
So, and then I was looking at, like, that's 21 years old.
Yeah.
And then 1975 is the other TV down there. That's 30 years old. No, it'd be 60 years old. 50 years old,
Yeah,
I'm sorry.
You got two of them.
This one.
So you can see the progress of portable TVs from
Yeah, no kidding.
60, 50 years ago. I mean, that looks pretty good. I don't know whose that is.
Yeah, it's reads. Does it work?
Oh, it's on 12 volts. I first trip to Japan was in 1975. I noticed that the Japanese had transistorized television sets. Unlike the U.S. with TV, then it was all vacuum tube based. So I bought this transistor set. It's a 1-tube radio, the cathode ray, still a vacuum tube. And since then, of course, all TVs have become transistorized.
So this was a very early transistorized?
Very early, I think 1975.
And you bought it in Japan?
Yeah.
Who's it made by?
Sony.
Well, they won't make it.
Cool. There's another Sony.
That's color. Yeah, they sold that for a very short period. I understand they actually recalled them. They didn't want them on the market anymore because they were so unreliable and frankly didn't get a real good picture.
Huh. Wow. Have you
tried? It's early 70s, I forgot. There's some write-ups about them. You know, people do go after them and collect them because they are kind of hard to find. But it was available in a white cabinet and that dark cabinet. It has a separate wall wart that goes with it. But like I said, they were plagued with the problems of leaky electrolytics. And the leaky electrolytics would also eat the copper foil away. So that's why they didn't want to work on them, and nobody wanted to fix them because it's so cramped in there. I never actually opened the thing up.
They have the service manual.
Got the service manual, yeah.
Is that color?
Yeah.
Is it color?
It's color.
Is that a flat screen or a tube in there?
No, they call it an indextron. It's similar to a LCD screen. Huh. Very similar.
Wow.
Yeah, it looks flat.
The other thing there, if you pick it up from the bottom, the Panasonic unit, pick it up from the bottom, yeah. The front of that thing is a clock. That whole front is a clock and the radio dial. Now tilt the top of it back.
Oh, wow.
That's space age, man.
It was designed to be like it's next to a bed or something, and yeah, when you in that position, it's a nice TV. When you flip it up the other way, it's a clock radio.
Yeah, it's so cool. I've never seen that.
Very cool. Wow.
Panasonic.
Does it work?
Yeah, I plugged it in yesterday. It comes on. Does it play out on Bootsy? No, only leave it to you.
Oh, okay.
Only leave it to you.
Ben has a little Casio.
Yeah, it's just it's a little colour TV. It would work if it was anything you could listen to. I mean, lights up, tunes and all that good stuff. There's nothing there.
I was gonna say,
1992.
You don't really have anything to watch on any of them anymore, though.
No.
1992 it dates from. Made in Japan.
The converter box is
yeah.
It's very neat.
old VCR recorders.
All right,
There you go.
very good.
All right.
Yeah.
Thank you for everybody who brought those in.
That's cool.
Silly me, I thought you were gonna bring in like a 1956 portable TV. It's standing across my mind. Any questions, thoughts? Next month, August 8th, we are working on a two-part, on your right, presentation on oscilloscopes. It's not going to be just, well, plug it in here, don't plug it in there. Literally starting, and it's going to be a multi-presenter, multi-day presentation. Like Paul's, one of the things she's going to talk about, starting at the beginning. What is a sine wave? How do sine waves exist in nature? How do they exist in technology? Because without those, forget the scope, right? So it'll kind of go through several phases and pieces. It'll be a safety element, obviously, but it's more than just a how-to. There's some how-to, but there's some why is. Is that correct English? Probably not. So we're still working it out, but it'll be August and September if all things go to plan. You're multi-presenter. We've never done that before. We've never done well, I think you've actually done a two presentation. Yeah. So a little bit different here. We'll keep you posted. Still work in progress, but that's the plan for August and September technical presentations. Show and tell. Radios used in television and movies. What do you have that was also in a prop? Do you have an XYZ? Do you have a Walton radio?
Yeah,
because it was in a Walton. Bad example, I know. So if you have radios and stuff, I got one, Gilligan's Island. If you have something like that that you know was used in a TV or movie, and it's movable, we'll bring it in. So that's kind of where we are. Any questions, any thoughts? Please make sure you filled out the sign-in sheet. Next month, I'll have a space in there for phone numbers, so we'll have to do the phone number as well. Go to the web, watch the videos. We're on eBay, no we're not. That's it. We'll see you next time.